Hello AI students. This video is a shorter reprise of a walking through a hello world of neural networks, training a single neuron, that we did in class. In class, the students all opened up the code and worked on it while I did it in front of them on the projector. But this is a video, so you can just watch this or you can work it along as you wish. From Blackboard, you can download this Python notebook. It's called Easy Equation NN5.IPYNB, and you can run it in Google Colab. And I'll put the link to Google Colab also in Blackboard so people have that. If you're not familiar with Python notebooks, we'll try to find some help for you to help you do that, to learn that real quick. But you can certainly watch this and understand it. This particular notebook, my friend and I stole it from a class, an online class in TensorFlow, and then we added a lot of explanation to it and modified it quite a bit. So this was started from them, and then we moved it. It's under an Apache license, so we're allowed to take their stuff and modify it as long as we credit them with the original. So this is going to be a neural network which just computes a linear equation. That's all. And the key here is going to be to notice not that it computes a linear equation, because as you will, when you saw the definition of how a neuron works, the input value is multiplied by a weight, and so it's a linear equation. So the miracle is not that it computes a linear equation. The miracle is that it's trained. That this neural network has no idea that what it is trying to model is a linear equation. It has no idea what the coefficient is, no idea what the constant value is. It learns it, and it learns it just by looking at data. And every time it looks at some data, it gets an input value, it has an output value, it nudges in the weights in the equation in the right direction until eventually it converges on something very close to the answer. So let's take a look at that right now. The equation here is y equals 2x plus 1. That's not hard. Again, this is a notebook. If you're not familiar with it, the basic idea is that it's divided into cells. Some of these cells, here's a cell which contains just comments. It's called markup. So here's another comment cell. So I mean, they're much more sophisticated than plain old Python comments. And here we have a cell which has just a little bit of Python code, and I can click here and run it. So it's like we're looking at a listing of a Python program, and a little piece at a time I can run these lines. I just ran these lines, which was all imports. And now I've paused the program and I've got my finger on it, and this is the next line of the program. So we're going to then execute the program a little chunk at a time. And that's the basic idea behind the notebooks. You could also execute the whole thing from the beginning to the end. All right. So what are we looking at over here? What we're looking at is a neural network is going to be a Python object. And this over here is going to make a Python. This is a constructor. It's going to construct an object and put it in this variable called model. And it's going to be, again, this is a hello world. This says that it's going to have a single neuron. That's units equals 1 is a single neuron. And the input shape, if you remember before, we had our features coming in with the weights. Okay, The input shape here is the shape of that features, which is going to be an array here with only one element. So it's just a single linear equation of y equals, x plus 2x plus 1. So the input value is going to be just that value of x. So if it was that cat thing before, then we would have had a one-dimensional array of 5 numbers would be our input shape. If we're processing a picture, it's actually normally going to be 3 dimensions. It's the height and the width of the pixels, number of pixels wide and high, and then 3 layers of the array for the red, green, and blue. So it would be a 3-dimensional array where the 3rd dimension is red or green or blue. So the input shape are the features. The last thing to notice here is that this is a list. This is a Python list containing one thing with an input shape in units. Okay? A neural network with several layers will have a longer list. So this would be the first layer, and then there'd be a comma over here, and then over here, and then there'd be a second layer like that. So this cell calls the constructor, makes a neural network object. That neural network object contains one neuron, which is expecting one input. Okay, and that's it. And then all the code in this, all the comments in this notebook explain what I just explained to you verbally, so you'll have that written down. A nice thing is that these objects have a method called summary. So if I click on there, I call the summary method, and it prints out this stuff here. Okay, and this is telling you that it's got just a single neuron, and dense is something that has to do with the interconnectedness, but with only one neuron, the fact that it's dense, who cares? You'll notice here that it says 2 parameters. You're going to get used to looking at the number of parameters. There's 2 trainable parameters. And what that's telling you is that when it's busy nudging the numbers to the weights in order to get them into the right answers to come out, there's 2 of those things that it's nudging. And that's actually the slope of the line, that's the first weight, and the constant part of the equation, like that. So, as I mentioned, when we were seeing a single neuron, there's usually a constant term. So both of these are trainable. The slope and the intercept, those are both trainable. And so it's telling you that there's 2 layers there. Okay. Now, what we haven't really specified, this is like the architecture of the network. What we haven't specified is what's the algorithm that's going to be used to train it. So it turns out that turning our model, our object containing the neural network architecture, into something that can be trained is called compiling it. And in order to compile it, we need to specify 2 things. One is going to be how we measure the error. So we could just say that the number coming out of this neuron, compared that to the correct number, and just subtract that. Or we could have more sophisticated errors, and any of you who have taken statistics or something, or linear modeling, recognize the value of mean squared error. So you square up all the errors, and then you take the average. So we like to use things like the squared errors, because that means that outputs that are further away from the desired answer contribute a lot more than disproportionately more. We're going to be attacking the really wrong outputs. We're going to attack them harder. They're going to be more significant. The next question is, what's the mathematics that's used for nudging those weights in the right direction. And you don't really need to know what most of those algorithms are. We're using a very popular one here called stochastic gradient descent. And just accept that there's a couple of other optimizer algorithms, they're called. You'll learn the characteristics of each of them without needing to know the mathematics. Let me just say that partial derivatives are involved. Okay? And that gets us through creating our neural network in software. We still haven't trained it yet. We haven't tried it or anything like that. This is just the code to create the neural network. And you'll notice it wasn't very much. It was the imports. It was specifying the model, and then compiling the model, meaning specifying the, where is that one? Okay. Compiling the model, specifying how we're going to train it, the method that's going to be used for training it. And again, we put lots and lots of comments in here to explain what I just explained.